being here today. My name is Allie Howe. I am the founder of Growth Cyber. We help AI startups with security and compliance, so things like SOC 2 and AI security. And let's see if I can pull up my presentation. Awesome. Okay, so I'm helping AI startups with security and compliance now. Previous to that, I was a software developer at startups, and I got to wear the security hat, which is really fun. I'm sure many people can relate to that. And so I've got a software engineering background by trade, and for fun to understand sort of what my clients would be building and using, I built a multi-agent system like for fun, just to sort of like understand the risks and sit in their shoes. And so, so I built a system that deals with patient data. And then in this talk, which I'll try to go through pretty quickly, we'll talk about what I built, what it was vulnerable to, what you might be needing to pay attention to while you're building AI agents, and then sort of like what the future looks like for privacy and security for agents. Just to start off, I know this is the agent summit here, so we all probably know what an agent is. But I really like this breakdown into thinking about an agentic spectrum, because I think it's not a one size fits all definition. I think on the less agentic side, we have LLM workflows where different LLMs are chained together to have more of a deterministic set of tasks to do, where we sort of expect the same problem to be handled in the same way, and so we can have sort of a planned out workflow. And in the middle, we have an agent that is able to take the output of an LLM and then decide, okay, given this output, what tool should I call, or what action should I take next? So it's able to, take that LLM output and then decide what to do next. And then all of a sudden on the most agentic side, you could have a fully autonomous system, think of a self-driving car, for example. So where you fit in this spectrum sort of depends on what you're building and what your use case is. And sort of the spoiler alert is not everybody needs to be building a self-driving car. You might just be fine with an LLM workflow if you know your problem and you know the steps that are needed, and that there's a lot less complexity in terms of security on this side, but on the way on the other side, there's a lot more to worry about. So definitely tailor your use case to what would be most appropriate. And then, so for enterprises that are building with AI agents today, there's a lot of different use cases. I think other speakers talked on this, where Microsoft Copilot's really popular. In Salesforce, you can build your own agents, and same with Power BI. And there's a big use case and a big economic potential with agents. I think that's why companies are adopting them. I think it was Sequoia that said the total addressable market for agents is 3 times larger than traditional SaaS. So tons of economic potential here. We need to lean into AI agents. And so we need to be enabling this adoption, this innovation from a security perspective. So I think security has a great place in being able to sort of help enable this innovation. As far as agent frameworks are going with, so when I built my multi-agent system, I was thinking okay, what am I going to use to build this with? I'm not going to maybe build it from scratch. I'm going to use one of the frameworks that's out there. There's quite a few out there today. I think some of the popular ones are, on this list, and there's lots more as well. Mastro is a TypeScript AI agent building framework. Pydantic is built on Python. Lots of different options. I built this example on LangGraph, and I used LangSmith to sort of observe what was going on. So at a high level, what I made was a 3-agent system. There was a supervisor agent that manages 2 agents below it. Agent 1 was a clinical researcher agent, and its job was to perform web scraping on the web to go out and view different clinical trials for a condition called ALS, and find what trials are available and what is their length of study, what is the criteria for patients to be accepted to those trials. And then Agent 2 was connected to a database full of patient information. It was a fake database that I created with a script from ChatGPT. So it was fake patient data in there, but it was all related to patients with ALS. And so the prompt that I gave it was, find ALS clinical trials and then based on the data we have in the database, recommend which patients would be most appropriate for those trials. And so behind the scenes, like in my system prompts, like what I did was like make sure, like given their data in the database, are they going to outlive the length of the study? And based on that, like they would be a good fit or not. So like I said, yeah, I use LangGraph. I also use like LangSmith as an observability platform. There's multiple different observability platforms out there spinning up now. I think Pydantic AI has launched their own as well. This is LangSmith is framework agnostic, so you don't actually have to be building with LangGraph to use LangSmith, which is kind of interesting and neat. But I found that was really helpful for debugging and seeing like what the agents were calling behind the scenes, like what websites we were web scraping and what SQL queries we were generating to find patient data in the database. But one of the things I found that my system was vulnerable to, without really, trying really hard at all to either prevent it or even cause it, was prompt injection. And there's several different types of prompt attacks. Indirect, where we're submitting a malicious prompt to the AI system, which is like a direct prompt injection. Indirect would be like if you went to web scrape the web pages that I was talking about, and there was malicious information embedded on that web page. Now suddenly could be a malicious prompt into your system. And also jailbreak attacks. And this is kind of what an example like jailbreak could look like. That's from Lakera AI. So this is a demo that I had created to showcase how my system was vulnerable to prompt injection. Basically, what happened was I was able to ask for individual patient data from the system, which was not as intended. The goal of the system is to output a list of patients that fit the trials. It's not supposed to output singular patient data. But if I asked, like, what was Wendy Lee's FVC percentage, for example, I was able to get that back without the system mitigating that at all, or saying, no, like, that's not allowed. You're not supposed to return individual patient data. So 2 ways I was able to mitigate this was I found if I added more to the system prompt, I was able, and said, like, we're not supposed to return individual patient data within the system prompt. It was able to stop that from happening. And I also found that like that works part of the time, but not all the time. It's kind of like Michael mentioned at the beginning. It's like, we can just find every time we find a problem, we add it to the system prompt. We could do that all day. We'll find more and more problems that the system prompt, may or may not prevent. So I needed like additional guardrails. And for that, I started writing, functions at the beginning of like, try to figure out like using like regexes and information. Is there like a patient name in the prompt, which would be indicative of like, okay, maybe we're asking for individual patient data. And you could write validation functions all day long too, but there's going to be use cases that you miss. And it's like, okay, like, thinking about me as a developer, I'm just trying to write this application to be able to, help patients find ALS trials. Like, I don't want to spend all of my time mitigating prompt injection. So thankfully, there's lots of different like really great vendors out there that are creating guardrails that you can use and integrate them like via APIs to be able to detect things like prompt injections or PII, such as like individual patient names. So I found that those were really helpful. And that's something that I was able to, after my testing as well, I felt pretty confident that I was resistant to that, more or less after those mitigations.
Message.
So that's just like a video of me doing that, but I kind of already talked through it, so I'll skip it. So another one, which is on the OWASP top 10 for LLMs, is excessive agency, which I feel like other speakers have mentioned as well. But basically, like, you want to make sure your agent is scoped to your use case you're trying to solve as much as possible. Don't give it excessive permissions or functionality. So in my example, the way this played out was my agents had read and write access to my database. And that was problematic, which I can show you as well. So I think I have a video for that also. But basically what happened with this is I was able to ask it to change a user like called Wendy, change her FVC percentage to a different value, and the agent would comply with that without even thinking, about it or thinking twice. And there's two ways I was able to mitigate this. In the system message, I said you shouldn't, execute any SQL queries related to modifying data. So that helped solve it as well. Didn't solve it perfectly. I still found that I had to change database access to be read only, not write, for it to be able to feel like more confident that this agent would not be able to manipulate the data that's in our database. So that kind of goes to show a defense in depth strategy is best with agents, which I feel like other speakers have mentioned as well. Don't just focus on one mitigation, like putting more into your system message. Like, yes, that helps a little bit. You're still going to find other use cases where that fails. So if you make sure that your agent is scoped to just solve the problem that you're intending it to do and only giving it the access and the permissions that reflects that use case, that would be best. Like, there's no reason that this system, based on what I need it to do, needs write access to the database. So there's no reason that it should have write access.
Change a patient.
So other vulnerabilities to be aware of as well with agents can be like memory and session poisoning, making sure that your context kind of gets cleared. Like every time a new user chats with it is important. So you imagine like in a healthcare application, if you had a chatbot and, patient A was chatting with it and there was sensitive data to exchange, like if patient B comes along next and starts asking questions, it shouldn't be getting patient A's data back. So making sure that we're clearing our sessions and handling that appropriately is important. Supply chain is big too. Agents do use LLMs like under the hood, and there's lots of different choices out there, closed source, open source. I think we're seeing a trend where we're expecting closed source LLMs to have more, AI safety and security and guardrails like baked in. That's a shared security model as well. Like just because, they're able to have some of that built in doesn't mean that you don't need to focus on it as well. I would definitely, still invest in like AI runtime security and making sure that you have some sort of a solution in place to monitor for different prompt injections and prompt attacks and sensitive data like being output as well. I think supply chain is important too. There's this whole new piece out there called ML SecOps, which you may or may not have heard of, but basically like ML engineers and data scientists, they work differently than your engineers of the past do. Your normal DevSecOps tools might sit in a GitHub CI/CD pipeline, but your ML engineers are working in places like Databricks and Jupyter Notebooks, where those tools don't normally sit. So with having some sort of an ML SecOps focus or a solution where you're looking for like leaked secrets and those like Databricks platforms, for example, is important, and making sure you understand like model provenance, like where did this model come from, who made it, what are their motivations, what data was this model trained on, are you able to output like an AI bomb, for example, that's able to show sort of a listing of all the data it was trained on and where that model came from. That's really great from a compliance standpoint as well, to have access to that information. But yeah, lots of things to worry about with agents. We are making great progress on being able to secure them. But yeah, one final takeaway that I'll share that I sort of mentioned in the beginning is agents are wonderful. Workflows are great too. So if you have more of a problem where it's more well defined and you understand exactly like the steps you need to solve it, maybe a workflow is great. Chained LLM calls are great, but if not, like then do something more complicated with an agent if you need to. So I think that's all I have time for. But yeah, thanks so much for listening.